In this class, we will be studying MN test, which is used to check the convergence, or which is used to check the uniform convergence of a given sequence of functions. तो MN test क्या है? Statement MN test it says let A be a subset of real numbers. This R is the notation for such set of real numbers. So let A be any subset, and for each small n in the set of natural numbers, let fn from A to R be a function. Be a function. Also, assume that sequence fnx converges to function f pointwise on the set A. It means that for every point in A, the corresponding sequence of functions will be convergent to fx. That is, we can write this as limit fnx n approaches to or n tends to infinity. This will be fx for all x belongs to the set A. Now define m subscript n supremum of modulus fnx minus fx mod such that x is coming from the set A, right? Then this sequence of function fnx, this converges to the function fx on the set A uniformly. This sequence of function converges to the function f on the set A uniformly if and only if the mn this tends to 0 as n tends to infinity, or you can write limit of mn is 0 as n tends to infinity. You can also write this, both the things are same. So ये स्टेटमेंट है कुल मिला के mn टेस्ट की. लेट a be a subset of r, एंड हर एक n के लिए हमने एक फंक्शन डिफाइन किया है फ्रॉम अ सेट a टू द सेट ऑफ रियल्स, है ना. एंड एज्यूम किया है कि ये जो सीक्वेंस ऑफ फंक्शंस है, दिस सीक्वेंस ऑफ फंक्शन कन्वर्जेस टू द फंक्शन f पॉइंट वाइज ऑन a, है ना. पॉइंट वाइज का मतलब क्या होता है? पॉइंट वाइज का मतलब ये हुआ यहां से for each x naught in the set A, the corresponding sequence of functions, the corresponding sequence of functions f and x at x naught, this will be a convergent sequence. And you are familiar with this, that this is a sequence of real numbers. After substituting x to be x naught, you will get a sequence of real numbers, and this sequence of real numbers is convergent for every x naught in A, and it converges to, and limit is, it converges to the value of f evaluated at the point x naught. This is the meaning of point-wise convergence. For every point in A, we are getting a convergent sequence of functions. And we have defined Mn to be supremum of modulus fnx minus fx, such that x is coming from set A. Then the convergence is uniform. Then this convergence is uniform if and only if this Mn tends to 0 as n tends to infinity. Okay, so this test is known as Mn test for uniform convergence of sequence of functions. प्रूफ ऑलरेडी मैंने किया हुआ है, आप प्लेलिस्ट में जाके इसके प्रूफ को देख सकते हैं, वो मैंने पहले ही किया हुआ है, उसको आप देख सकते हो. So let's start with an example how to apply this test for a given sequence of functions. The question is, discuss the uniform or show that the sequence fn where fnx is given to be nx divided by 1 plus n square and x square. This is not uniformly convergent on any interval containing 0 point or 0 number. So solution: let fnx to be nx plus n square x square, right? It says this is not uniformly convergent on any interval containing 0. Now the first task is to prove that this sequence of functions is pointwise convergent on a given domain. Domain is your any interval which contains 0. कोई सा भी एक ऐसा interval जो 0 contain करो, that is your domain. ठीक है? So it says this is your domain A, B, right? And it contains 0. So A can be 0 as well. So this will be your domain. This is your set A, B, and it contains 0. Now at x is equal to 0, fn at 0 is 0, n into 0 0 divided by 1 plus n square into 0, that is 0, which is 0 by 1 and hence 0. So we are getting a 0 sequence and this is a convergent sequence, है ना? तो sequence क्या है हमारे पास? fn at 0, this will be your f1 at 0, तो f1 at 0 will be 0, 2 रखो यहाँ पे 0 मिलेगा, 3 रखो, f3 is also 0, so 0 0 0 0, and this is a convergent sequence and it converges to the number 0. So limit fn at 0 is 0. Now for non-zero x, limit of fn x as n approaches to infinity, this is limit n approaches to infinity, nx divided by 1 plus n square and x square. n into x, we are taking x square common from this bracket or from this expression, 1 by x square है ना plus n square. So since x is a non-zero number, so x and x gets cancelled out. So limit n approaches to infinity, n by, this is 1 by x square, uh, we are left with x, right, n square into, so x से x cancel हो गया, so we are left with only x. So as n goes to infinity, this number goes to 0, this number goes to 0. You can take x outside, 1 by x outside, so this is limit n by, or you can write this one as you can write this one as limit n by x, है ना, इस x को हम ऊपर ले गए, इस x को ऊपर में ले गए, n by x and n square we are making a mistake here, we are making a mistake, so let's improve our mistake. Instead of taking x common, we should have taken n common, so nx n square 1 by n square plus x square, so n and n gets cancelled out, we are left with x by n, है ना, एक n बच गया यहाँ पे, उस n को हम ऊपर ले जाएंगे and in the denominator it is x square plus 1 by n square. So as n approaches to infinity, जैसे ही n infinity को approach करेगा तो ये number किसको approach करेगा, this number will approach to 0, है ना, ये नंबर किसको अप्रोच करेगा, 0 को, जैसे ही n जो है infinity को अप्रोच करेगा, और ये this 1 by n square this also approach to 0, ये भी 1 by n square 0 को अप्रोच करेगा, एंड x square से हमारा कोई लेना देना नहीं है, x is any number, so overall this is 0 by x square, ये हो जाएगा, फिर this will tend to 0 by x square, है ना, and which is nothing but 0, so limit will be 0, limit is 0, so at x is equal to 0 limit is 0, and if x is non-zero then limit is also non-zero. So we can write, we can define a function, define function f from a to r by where a is an interval containing the point 0, f of x to be limit n tends to infinity fn x, right, so this is nothing but 0, this is 0 for every x in the domain a. Now where you can write here, or you can mention here, a is an interval, a is a subset, a is a subset of real containing the point 0, containing 0 number, right, 0 point, so that is f of x is 0 for every x in A, right? So now we are in a position to say that this sequence of function f and x, this converges to the function f point wise, right? यानी हर एक पॉइंट पे कन्वर्ज कर रहा है सीक्वेंस पॉइंट वाइज ऑन अ गिवन डोमेन A where A is a subset which contains the point 0. Now Mn is supremum, Mn is supremum modulus of fn x minus fx, right? X is coming from the set A, so this will be supremum of this fx is 0, fx to 0 है, so it is simply modulus of nx plus 1 plus n square x square, right? Minus 0, you can write minus 0 if you are interested, you can write here, and x is coming from the set A. So see, x is n x, so this is supremum of, you can this write, x is coming from A modulus nx by n square x square. So we are interested in supremum of this set. हमें इस सेट का सुप्रीमम चाहिए. किस सेट का सुप्रीमम चाहिए? ये जो सेट है nx by 1 plus nx square, x is coming from set A. So we have to find the supremum of this set, and that will be our Mn, right? So how to find the supremum of this set? I'll tell you a trick or a method which is very useful. First of all, whatever the function is inside this modulus, assume that function to be some function of x. uh, let you can write let y, ठीक है, let y to be this function, let y to be nx, इसको हमने y मान लिया, a function of x, n square x square, right? अब हम क्या करेंगे? We will find its derivative, first derivative y prime, or you can write simply dy by dx, ठीक है? तो फर्स्ट डेरिवेटिव हम निकालेंगे इसका, तो इट इज ऑफ द फॉर्म u by v, तो फर्स्ट डेरिवेटिव फॉर्मूला निकालेंगे, नीचे का जाएगा इन द डेरिवेटिव इज n square x square होल स्क्वायर, देन डेरिवेटिव ऑफ nx का डेरिवेटिव क्या होगा विद रिस्पेक्ट टू x, दैट इज n into 1 plus n square x square minus nx into the derivative of this one, that is 2n square x, ठीक है? After simplifying this, you will get n minus n cube x square, and in the denominator 1 plus n square x square, right? Now for y to be maximum, क्योंकि हमें इसी का मैक्सिमम फाइंड करना है, for y to be maximum, put this derivative y prime, which is your dy by dx, put this thing is equal to 0, so ये हो जाएगा n minus n cube x square, it is 0, and it will be 1 minus n square x square is 0, right? और यहाँ से हमें क्या मिलेगा? n cannot be a 0 क्योंकि n is a natural number 1 to 3, so it cannot be 0, so it has to be 0, right? 1 minus n square x square, this has to be 0, so we can write this one as 1 square minus nx का this to the whole square. This, so it is of the form a square minus b square. We can break this one, a minus b into a plus b. So 1 minus nx multiplied by 1 plus nx. So it is 0. Now either 1 minus nx is 0 or 1 plus nx is 0. From here we are getting x is equal to 1 by n, and from here we are getting x is equal to minus 1 by n, right? So we are getting 2 points. Now we have to check its double derivative y prime, that is d square y by dx square, that is d by dy of d by dx of n minus n cube x square divided by 1 plus n square x square, and this to the whole power 2. So it is coming out to be, I am writing here directly, you can compute this one, right? So it is coming out to be minus 2 n cube x 3 minus n square x square 1 plus in the denominator 1 plus n square x square whole power 3, right? So we are getting 2 points 1 by n. So हमें ये चेक करना होगा कि at which point this y double prime is strictly less than 0, then we will have y is maximum at that point. y is maximum at that point. Y is maximum at that point, right? So at x is equal to minus 1 by n, at x is equal to minus 1 by, this will be positive, ये positive हो जाएगा, ये क्या हो जाएगा, you have to verify this will be positive, है ना? जब हम x को रखेंगे minus 1 by n, तो y प्राइम क्या हो जाएगा, y प्राइम पे रखो x को minus 1 by n. देखो ये वाली जो क्वांटिटी है पहली वाली, ये यहाँ पे होगा minus 1 by n, ये माइनस और माइनस पॉजिटिव, ये पॉजिटिव हो जाएगा टर्म, ये टर्म पॉजिटिव हो जाएगा, और यहाँ पे हमें मिलेगा 3 minus 1 which is 2, ये भी पॉजिटिव हो जाएगा. सो पॉजिटिव पॉजिटिव पॉजिटिव, और ये x स्क्वायर है, x स्क्वायर, इसका x स्क्वायर करेंगे तो क्या आएगा, पॉजिटिव. सो कुल मिला के जो हमारी होल टर्म है दिस हैज टू बी पॉजिटिव. तो y प्राइम जो है वो एट दिस पॉइंट इट इज कमिंग आउट टू बी पॉजिटिव. सो यहाँ पे हमें मैक्सिमम नहीं मिलेगा, यहाँ पे तो हमें मिनिमम मिल रहा है. सो दिस कैन नॉट बी अ पॉइंट ऑफ मैक्सिमम. सो this cannot be a point of maximum. So now at x is equal to 1 by n, y double prime or y double derivative at x is equal to 1 by n, it is coming out to be minus n square by 2, right? And which is obviously strictly less than 0. So this is a point of this, x is equal to minus 1 is a point of, therefore x is equal to 1 by n is a point of maximum, maximum. So ये जो हमारा फंक्शन था mn was supremum of the function nx by 1 plus n square x square, है ना? और x कहाँ से आ रहा था, सेट A में से। इसको हमने y माना था, और इस फंक्शन का मैक्सिमम कहाँ पे मिल रहा है हमें, इस पॉइंट 1/n पे। तो 1/n रखो यहाँ पे, सो इट इज n इंटू एक्स की जगह 1/n, 1 प्लस एन स्क्वेयर इंटू 1/, ठीक है। सो ये कैंसिल हो जाएगा, ये भी कैंसिल हो जाएगा, इट इज 1/1 प्लस 1, सो mn इज कमिंग आउट टू बी हाफ, राइट। तो 1/n, x हमारे पास पॉइंट था 1/n, सो इट बिलोंग्स टू, क्या ये पॉइंट सेट A में बिलोंग करेगा? नाउ द क्वेश्चन अराइजेस, yes, because this set A contains the point 0, this set A, since A contains 0, A contains 0 and 1/n tends to 0 as n approaches to infinity. So ये जो 1/n पॉइंट होगा ये सेट A में बिलोंग कर जाएगा, क्योंकि जैसे जैसे n बड़ा होता जाएगा ये 1/n जो है वो 0 के पास, so we can choose this point 1/n, this set A. So obviously this A contains point 0 as 1/n approaches to 0, as n approaches to infinity, so 1/n is a point of A, राइट। ये चेक करना पड़ेगा हमें, यहाँ से जो भी पॉइंट निकलेगा उस पॉइंट को हमें चेक करना होगा कि क्या वो पॉइंट सेट में है, only then we can say ना। So this is 1/2 and the limit is also 1/2 because it is independent of n as n approaches to infinity, so mn approaches to 1/2 and which is 1/2 is not a non-zero, as so by mn test, using mn test वो कहता है कि अगर ये 0 पे टेंड करा, if and only if, so necessary as well as sufficient condition है वो, तो ये 0 पे टेंड नहीं कर रहा है, तो इसका मतलब ये हुआ कि given sequence of function f and x does not converge uniformly, fx uniformly on A, ठीक है। So the given sequence of functions does not converge in any interval containing point 0, 0 पॉइंट को जो कंटेन करे, so it is not, है ना। आपको मुझे लग रहा है ये पॉइंट समझ में नहीं आएगा कि x is equal to 1/n 0 इस इंटरवल A का पॉइंट, इस सेट A का पॉइंट कैसे हुआ। देखो n is coming from the set of natural numbers, right, n is coming from the set of natural number, so we can find 1/n as close to 0 by taking n to be, or by approaching, or by tending n towards infinity. So we can find such a point in a neighborhood of 0 always, हम 0 के neighborhood में 1/n टाइप का पॉइंट हमेशा फाइंड कर सकते हैं by choosing n to be, by choosing n to be very very large, sufficiently large, right. So ये जो है this given sequence point, this does not converge uniformly on the given set A, right. So सबसे पहले हमने क्या किया, mn टेस्ट की यहाँ पे हमने स्टेटमेंट देखी। mn टेस्ट क्या कहता है कि सबसे पहले जो गिवन फंक्शन, जो सीक्वेंस ऑफ फंक्शंस है दैट शुड कन्वर्ज पॉइंट वाइज ऑन द गिवन डोमेन A, ओनली देन यू कैन प्रोसीड, राइट। उसके बाद आप प्रोसीड कर सकते हो। उसके बाद हमने mn फाइंड आउट किया। mn के बाद हमारा यहाँ से क्या निकला, एक फंक्शन निकलेगा, उस फंक्शन को आपको अज्यूम करना है y, ठीक है। लेट दैट फंक्शन भी y, यहाँ से जो भी फंक्शन निकला, जैसे यहाँ पे देखो आप, ये तो हमने दिखाई यहाँ पे पॉइंट, ये हो गई हमारी पॉइंट वाइज कन्वर्जेंस। पॉइंट वाइज कन्वर्जेंस के बाद ये यहाँ पे जो भी फंक्शन निकलेगा आफ्टर सब्ट्रैक्टिंग fx फ्रॉम दी fnx, जो भी फंक्शन निकलेगा यहाँ पे उस फंक्शन को आपको अज्यूम करना होगा सम फंक्शन ऑफ x दैट इज y एंड लेट दैट बी y। फिर y का फर्स्ट डेरिवेटिव निकालना है। y का फर्स्ट डेरिवेटिव निकालने के बाद उस डेरिवेटिव को for y to be maximum, because we are interested in the maximum point of we are interested in maximality of f, so for y to be maximum put first derivative to be 0। यहाँ से हमें कुछ पॉइंट्स मिलेंगे x के, यहाँ से हमें पॉइंट्स मिलेंगे, एक ये पॉइंट मिला हमें 1/n एंड -1/n, राइट। सो ये पॉइंट रखने पे हमें मैक्सिमम नहीं मिल रहा है, हमने चेक किया, फिर उसके बाद हमने डबल डेरिवेटिव फाइंड किया, क्योंकि अगर डबल डेरिवेटिव लेस देन 0 आएगा ओनली देन y इज मैक्सिमम एट दैट पॉइंट, अगर इफ इट इज पॉजिटिव तो उस पॉइंट पे मिनिमा होगा, सो y इज मिनिमा, y हैज मिनिमा एट दैट पॉइंट, सो where then we have applied the MN test, because MN test says if it converges to 0 then convergence is uniform, otherwise the convergence will not be uniform. So thank you. We will meet in the next class.